Okay, the next session is about graphical method of solving pair of linear equation in two variables. Okay, the most important term we are going to learn in this is about consistency. What is consistency? Consistency is the tendency of a pair of linear equations to have real solutions. They should have real solutions. So for consistency, there are of two types. They can be either consistent, or inconsistent. Consistent stands for they can have a particular solution or more than one solution, maybe, depending on the pair of linear equations in the two variables. Inconsistent refers to there is no solution, no proper solution that is present for the pair of linear equations. So we had learned about the three types of pair of lines. They were intersecting, coincident pair of lines, and parallel pair of lines. Okay, they need to be parallel. These two are considered parallel, maybe. Okay, this is intersecting, this is coincident, and parallel. In parallel, there is no solution since there is no common point. The common point for the graphs, for the lines, represent the solution for the given pair of linear equations. Here it was intersecting, and here also here we have one point that is in common. Here there are so many, all the points on both of the lines are common to both these lines, therefore consistent can be of these two places. Okay, so now about these three cases, how we are going to consider whether it is going to be an intersecting line or parallel lines or coincident lines just by seeing the pair of linear equations. There are several examples how they have come up from it is given in the textbook. I am not going to mention all those. What do you understand from that is just what I am going to tell now. Okay, so for that we are going to compare the values of a1, b1, c1 and a2, b2, c2 that is present in the general form of the pair of linear equations in two variables. There you have a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. So we need to comparison of that thing. So this is going to be the intersecting. So what is the case when it is intersecting? Why it should be intersecting? It should be a1 by a2 is not equal to b1 by b2. Okay, I can have any kind of example. Say I can tell x plus y is equal to 6 and 2x plus 3y is equal to 4. They have a particular solution. There is only one solution. That is, since it is intersecting, it can have only one common point. Number of solutions, I'll make it its column. Number of solutions, 1. Only one, because it is having only one point. Okay, next one is about coincident. That means that the lines are coinciding, the number of solutions are going to be infinite. So many other, since all the points are going to be coinciding. So what is the condition for this is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. a1 by a2 is equal to b1 by c2, b2 plus c1 by c2. Okay, this is the condition. Now we have set of parallel lines. Since parallel lines are going to be inconsistent, number of solutions is 0. They cannot have any particular solution for that pair of linear equations. So they are parallel. So what will be condition? Their condition should be similar to this. So for comparing a1 by a2, b1 by b2 and c1 by c2. Okay, these two are similar. This coincident and parallel are going to be similar because they are going to have the same slope from the x-axis. Okay, if you don't understand, leave that slope. They are going to be on the same tilting from the x-axis. That's the thing. So there should be some relation between this relation and this relation. So here it is going to be a1 by a2 is equal to b1 by b2, but it is not equal to c1 by c2. That is the thing. Here it was equal. If everything is going to be equal, then it is going to be coincident. If the first two are equal and the third one is different, then it is going to be a set of parallel lines. Okay. Before moving on to the exercise, I'll just do one example. That is example 4. Here it is given. First we need to check whether the pair of these linear equations into variables are going to have one solution, or they are going to be consistent or not. If they are consistent, it is asked to find out the solution graphically. Okay, till now we have learned only graphical solving. So for learning how you are going to get the point, I'm just taking this example. So this is first equation and this is the second equation. So for finding whether it is consistent, we need to have a1 by a2 not equal to b1 by b2. That is the intersecting case, or it should be the coincident case. Okay, we'll check which is going to be there. What is a1 by a2 and b1 by b2? c1 by c2, if wanted only we'll find out, because if it is not equal, c1 by c2 is no worried over there. a1 by a2 is 1 divided by 2. Coefficient of x is 1 there. Here it is 2, and you have 3 divided by minus 3. This is going to be minus 1 and this is, however, half. They are not going to be equal. Therefore, consistent. The pair of these equations are consistent. So now we have to find the values of x and y in order to plot the graph. Okay, better I'll take x-axis and y-axis only. The points on the x-axis and y-axis for my simpler condition. So I'll take 0 and like that. So what you're going to get here is 1 0 1 0. Similar I'll take here. So when I substitute this x is equal to 0, this is going to be vanished. You get 3y is equal to 6. 3y is equal to 6 means y is equal to 2. In the second case, y is equal to 0. That 3y is going to get cancelled. You have x is equal to 6 in that case. So x is equal to 6. Okay, now we have the second equation. Second equation is 2x minus 3y is equal to 12. You have x is equal to 0 in the first case. This is going to get vanished. You have minus 3y is equal to 12. Minus 3y is equal to 12 represents y is equal to minus 4. Okay, now we have y is equal to 0 in the second case. This is going to get cancelled. You get x is 6 is equal to 0. Just by finding the point itself, I got that 6, 0 has to be the common point of these two lines. But for formality, I'm going to draw the graph. Okay. Since they are going to be multiples of 2, I'll take 2 on both sides. 4, 6, minus plus 2, 4, 6, minus 2, minus 4, minus 6, 0. That much enough, I think. Okay, maybe 1 minus 2, I'll just mark. You need to write also the scale here, which is the scale, that is 2 units. Okay. Now we have 0, 2. 0, 2 steps upward. This is the point. You have 6, 0. 6, 0. Join these 2 points. Plotting of the graph is over. That is done. So we need to write the graph name, that is x plus 3y is equal to 6. This is first equation. Okay, I have not drawn a straight line. However, it looks like a line. Now we have x is 0 minus 4. 0, 4 steps down. Then you have 6, 0. So it is going to be joining this line itself. At this point, that is 6, 0. So I need to write the equation of that line, that is 2x minus 3y is equal to 12. This becomes the equation. So graphically we have solved that 6 comma 0 is going to be the common point of these two. Therefore 6 comma 0 is the solution for the pair of linear equations in these two variables x and y. Okay, now we are going on to the exercise. So you have exercise 3.2. The first question is just forming the equation. However, the remaining exercises are mainly based on forming the equation and then just solving algebraically. So I'm going to skip the first question. The second question is on comparing the ratios a1 by a2, b1 by b2 and c1 by c2. Find out whether they are going to be consistent or not. Or here the question is whether you need to find out that they are intersecting, parallel or coincident. That was direct because it was three cases where we had by telling a1 by a2 is not equal to b1 by b2 that for intersecting, then all the ratios are going to be equal for coincident, and it is not going to be equal to c1 by c2 in the parallel case. That's it. That is a direct thing you can find out. Now you have the third question. The third question is on again you are comparing. You have to tell whether it is consistent or inconsistent. It is going to be consistent if it is in the first or the second case, that is intersecting or coincident. If it is parallel, it is going to be inconsistent. So directly, those three cases are very important. So those three cases again you are going to apply to this third question also. Okay, now we have the fourth question. Fourth question again they are asked which is going to be the consistent or not. Based on the a1 by a2, b1 by b2, c1 by c2 ratios, you can find out that the first and the third subdivision is going to be consistent because the first one is coincident and the third one is going to be the intersecting form. Yes, the other two represent the parallel lines, therefore they are not going to be consistent. You need to just draw the graph for the first and the third one. So now I'll move on to the statement question, that is the fifth one. The fifth question is, you can see here, now you have half the perimeter of the rectangular garden. You have a garden whose length is 4 meter more than its width is 36 meter. Find the dimensions of the garden. So let me have a garden. I'll make my own garden here. So many crops I'll plant or something. Crops or something. These are some plants. So you have this. Okay, I'll take L and B instead of taking X and Y. I'll take L and B. Or let me take X and Y itself because I need to draw the graph, right? It's going to be irritating for me. It's going to be graph. So this X and this is Y. So okay, let the length of the rectangular garden be X meters and breadth be Y meters. This much we got. Okay, whatever it is, length or something. Okay, it is given that length is 4 meter more than the width. Length is 4 meter more than the width. That is length 4 added to the breadth, you get the length. That is the first equation. So I need to get it in the proper form. This comes to be x minus y is equal to 4. Let it be the first equation. The second equation says that half the perimeter of the rectangular garden is 36 meter. Perimeter of a rectangle is 2 into L plus B. So half of that becomes L plus B. L plus B stands for x plus y. Therefore, x plus y is going to be equal to 36. I need to represent this and find the dimensions of the garden. So for that, I need to form the equations. Not the equations, I mean the points. Okay, let me take 2 points only. X, Y. Okay, in the first case, I'll take 0. When x is 0, y is minus 4. When y is 0, x is 4. That is over. Now we have the second one. When x is 0, this is 36. When y is 0, x is 36. So that is how it is going to be the graph now. So maybe I need not take for the left part. because only y is negative, x is not going to be negative over here. So I'll more concentrate on this part. So this comes to be 4, 8, 12, 16, 20, 24, 28, 32 and 36, and you have one minus 4 here. Therefore this line is going to come in this manner because it has 4 0 and 0 minus 4. So you are going to get the line like this. You have again 4 here, 8, 12, 16 and so on, maybe some 36. I'm going to get it here, so I am not going to think about that. So it comes somewhat a line like this, and it is going to join here. This was x minus y is equal to 4, and this was x plus y is equal to 36. Okay, what was the point that is going to be equal in this case? So this comes to be approximately at this 16. Yes, it is coming approximately to be at 16. So one of them is going to be at 16 and the other one is about 16 plus 4, that is 20. It is coming here, right? This is 20. So this was the y-axis. Y is 20 and 16. Oh, it had to be coming like this because x is 4 more than y. Therefore it is going to be coming in this case, that is 20 comma 16. X is going to be 20 and y is going to be 16. If you draw the graph perfectly using the graph book, you can find out that this is going to be the intersecting point. Okay, so that is the solutions, or I can tell that 20 meter into 16 meter are the dimensions of the given rectangular garden. Okay, now we have sixth question. Sixth question is about, given the linear equation 2x plus 3y minus 8 is equal to 0, you are asked to find another linear equation such that it is going to be coincident, or it is going to be parallel or intersecting. That is just, you can write your own example, you are free to write, because it is, you are only thinking only about that ratios, that is a1 by a2, b1 by b2 and c1 by c2, how it is going to be when it is intersecting, parallel and coincident. The whole exercise is just based on this. So the next question is a little bit different, so I'm going to do that. Now we have the seventh question. Let me read the seventh question, that is here. So now we have the draw the graphs of the equations. So let me write the equation on the board. Equation is x plus y minus 1 is equal to 0 is the first one, and the second one is 3x plus 2y minus 12 is equal to 0. This much I got. These are the two equations. So I need to draw the graphs for these two equations. And we'll think, okay, determine the coordinates of the vertices of the triangle formed by these lines and the x-axis, and shade the triangular region. You are asked to shade the triangular region. You are going to get by the formation of these two lines and one of the axis. Which is the axis? That is x-axis here. So first we'll draw the graph and then think about the triangle that is formed. So this is the first one. So I need to get the points x, y. So taking on the x-axis and y-axis, when x is equal to 0, y is equal to 1. When y is equal to 0, x is equal to 1. That was simple because the sum was 1. Okay, now we have 3x plus 2y minus 12 is equal to 0. Okay, so what is going to be? The point comes to be when, maybe I'll put x to be 0. When x is 0, y is going to be 6. Y is going to be 6. When y is 0, x is going to be 4. I need to just plot those two. That is the only thing I need to do now. This is 1, 2, 3, 4. 4 is enough. Here I need 6. 1, 2, 3, 4, 5, 6. 0, minus 1, minus 1. These many are enough. They are not important about the negative one. Okay, here it was x minus y, right? X minus y, therefore this point comes to be minus 1. Okay, this has to be minus 1, right? So I'll take one more point here, maybe minus 2. Minus 2 is the extra point that I'm going to take here. So for that I need to draw the graph. This was very simple because there is only so many points that are involved. So let me take 0, minus 1. 0, minus 1 is going to be coming here. And you have the next one, that is, okay, it was plus 1 right here. This was plus 1, therefore it is going to be positive with the y-axis, and it was negative. Sure. Okay. So this is the proper point here. And the second one was 3x plus 2y minus 12. Alright. So first of all, you need to write the scale over here. That's the first thing. Maybe what is required only I'll do. The other things I'll just rub off. So here I'll have 2 points, 0, 1. So it comes to be in this place. And you have minus 1, 0 that's going to be coming in this place. So you have 2 points. Okay, maybe I'll draw this in equivalent manner because here it is near. I'm not going to get it in a proper manner. So 4. This is the thing. So it is x minus y plus 1 is equal to 0. Okay, now we have one more, that is 0, 6, 0, 6 and 4, 0. 4, 0. Maybe this was the line. This comes to be 3x. 3x plus 2y minus 12 is equal to 0. That much I got now. Now what is the point here? The point here comes to be 2 and 3, right? 2, 3. 2, 3. So 2, 3. So if I feel that is going to be wrong somewhere, so I think 2, 3 is going to be right or something. So I'll just substitute in both of these equations and find out whether it is going to be the solution of both of these equations. So I'll put it 2, 3. So it becomes 2 minus 3 plus 1. 2 minus 3 is minus 1. Minus 1 plus 1 is equal to 0, correct? So now I'll substitute here 2, 3. 3 into 2 is 6 plus 2 into 3 is 6. 6 plus 6 is 12. 12 minus 12 is equal to 0. Therefore 2, 3 is going to be the particular point that is going to be the intersection. So the second part of the question says you are asked to shade the triangle that is formed by these three, and you are also asked to find the vertices of this triangle. So you have the vertices. This is the x-axis. So this is going to become the shaded region here. This is the shaded region. Now you have these points, that is 2, 3, minus 1, 0. That is this point. You have one more, that is 4, 0. That are the vertices of the triangle that is formed by these two lines and the x-axis. Okay, this is the thing. Thank you.